Welcome back to my channel. My name is Prachi Sharma, and this channel is about learning chemistry for 10th grade ICSE. So if you are a student struggling with chemistry and if you can't figure out how to memorize the compounds, how to write the equations, this channel is for you. You can join the Telegram channel as well, and you can reach out to me and let me know your queries directly. So, today is the session in which we are working on the last part of analytical chemistry. I divided this chapter into three portions, that was anion detection, cation detection, and the last is your alkali reaction with certain metals, metal oxides and metal hydroxides. So, let's get started. Towards the end of the session, we'll also be working on some important questions. So, make sure that you stick around till the end of the video and download the notes from the description box below. So let's get started. Alright students, let's get started with the session. So if you look at the screen, you can see I have divided this portion into three kind of flow charts for you, and in each of them we have the equations written. So I've tried my best to make it easier way to memorize these equations and understand what is happening. So let's begin with the first section. So the first section is when you have alkalis reacting with metals. What are alkalis? Alkalis are soluble bases and we are reacting them with active metals. In this case, we are just taking the examples of three metals in all of the three sections. So zinc, aluminium, lead for all of them. So let's get started with the first one. So in the first section, if you see, you have zinc reacting with NaOH and giving you Na2 ZnO2 plus hydrogen gas. And what is the name of this compound? Let me use a green color. So what is the name of this particular compound right here? That is sodium zincate. And this is potassium zincate. So in all of the three sections, if you notice, you have Na2 ZnO2, so that becomes sodium zincate. Then this is sodium meta-aluminate right here. Sodium meta-aluminate. Then this becomes potassium meta-aluminate. Now and this one becomes sodium plumbite. So I'll write that sodium plumbite. The bottom one becomes potassium plumbite. So this is how the names are. So if you think about it, you just have to memorize three names: sodium zincate, sodium meta-aluminate and sodium plumbite. Okay, three names. So first of all, sodium zincate. So zinc reacting with NaOH giving you Na2 ZnO2 plus hydrogen gas. And same thing will happen when you're reacting it with potassium hydroxide, that is KOH. So Zn plus KOH giving us K2 ZnO2 plus hydrogen gas. Okay. Now let's move on to the next part, that is aluminium. So aluminium is reacting and you also have water along with that because you need boiling caustic alkali. So for boiling you'll have water in that. So Al plus NaOH plus your alkali, that is water, along with that gives you NaAlO2 plus hydrogen gas. So NaAlO2 plus hydrogen gas. So how can you remember that? So your hydrogen gas is coming out, that is this. What are you left with? And this hydrogen is also gone. So what are you left with? You're left with NaAlO2. Okay. So Al is from the beginning and then two of the O's are left. So O2. And the same thing you can remember for the second one. Aluminium plus KOH giving you KAlO2 plus hydrogen gas. Now aluminium also reacts with fused alkali to give sodium aluminate. So this is fused alkali. Aluminium has also tendency to react with fused alkali to give you Na3AlO3 plus hydrogen gas. And what is this? This is sodium aluminate. Okay, sodium aluminate. Now let's move on to the next part, that is lead. So that is pretty easy. You have lead reacting with NaOH giving you Na2PbO2 plus hydrogen gas. If you pay attention on this, this is also coming out in the same manner. You have hydrogen coming out. So this is your H that is coming out. What are you left with? You're left with Na, Pb and O. Okay, and if you know how to make the compound, that is using cation and anion, positive and negative, so you'll be able to make this one, Na2PbO2. If you struggle with making compounds, please let me know in the comment section, and I will definitely make a video to help out, and you will be able to understand how the compound formulas are made. Okay, so that is Na2PbO2. So this is the first section, when your alkali is reacting with metals. In the next section, we are working on amphoteric oxides. So this is a very interesting topic. Okay, what is amphoteric oxides? So oxides or hydroxides which have a tendency to react with acid. So these type of oxides have a dual, you can say dual characteristics. That means if they are reacting with an acid, they end up behaving like a base, and if they are reacting with bases, they end up behaving like an acid. So what happens at the end? You end up with the equation that acids plus bases are giving me salt and water. Okay, so amphoteric oxides have a dual nature. So if they see an acid, they start behaving like a base. If they see a base, they start behaving like an acid. So such oxides are known as amphoteric oxides. Okay, so let's look at the definition. The definition says amphoteric oxides and hydroxides are those compounds which react with both acids and bases to give salt and water. Okay, so this is what your amphoteric oxide definition says. Let's look at an example. So if you look at an example, ZNO. So ZNO is reacting with HCl, giving us ZnCl2 plus water. So in this case, ZNO is behaving like a base. So this is behaving like a base. Then if you have ZNO reacting with NaOH, it gives you Na2, ZNO2 plus water. In this case, it is working as an acid. So at the end of the equation, you are just ending up with acids plus bases, giving us salt and water. So such oxides are amphoteric oxides. Now let's move on. We are working on amphoteric oxides. That is, so three examples that you can remember is ZNO. Then you have aluminium oxide, that is Al2O3, and lead oxide, that is PbO. That is also known as lead monoxide. So these are the three that we are working with. So let's start with the first one. So you have zinc oxide. So zinc oxide is white in color. Aluminium oxide is also white in color. And lead one is yellow in color. So you remember these three colors. Okay. Now if you look at these again, if you think about the names here, so the names are the same that you did in the previous section. You have sodium zincate, potassium zincate. Then on this case, you have sodium metaaluminate and potassium metaaluminate. And on the third one, you have sodium plumbite and potassium plumbite. Why do I specifically mention these names? Because in some important questions, we have seen that they can ask you the name of the products. So even if you know the equation, but you do not know the name of the product, you would still end up losing marks. So you need to know the name of the products also. So let's start with the first one, zinc oxide. So zinc oxide is reacting with NaOH, giving us Na2ZNO2 plus water. In the second one also, ZNO reacting with KOH, giving you K2ZNO2 plus water. Now, ZNO is an insoluble salt which on reacting with NaOH or KOH gives you a colorless soluble compound. Okay, so this is what you have to understand in this case, because in some questions they can ask you a white soluble salt, a white insoluble salt giving you a soluble compound at the end of a reaction. So what kind of compound are we talking about? We are talking about ZNO. Now if we move to the second one, that is aluminium oxide, you have Al2O3 reacting with NaOH, giving you NaAlO2 plus water, and same thing is happening with KOH. Now for lead, lead is yellow in color, and this also becomes colorless and soluble. So if they say you have a yellow colored oxide or yellow colored monooxide, so that would be lead oxide or lead monooxide. So PbO plus NaOH giving you Na2PbO2 plus water. So if you think about it and you see that okay, these equations are difficult to learn because the compounds are big, technically think about it, you only have to learn 3 compounds and everything else is similar. So you only have to learn Na2ZNO2, Na2PbO2, NaAlO3, and then everything is being formed from the same thing, and all of them are repeated in the amphoteric oxide section and amphoteric hydroxide section as is. So if you understand the first set of equations, you can easily form all of them. So make sure that you pay attention on any one section, memorize them very well, and eventually you'll be able to make all of the other equations on your own. So instead of just mugging them up, try to put in some logic and then understand and memorize them. Okay, it would be easier for you to recall them during the examination. Now let's move on to amphoteric hydroxides. So amphoteric hydroxide, you have zinc hydroxide reacting with NaOH giving you Na2ZNO2 plus water. Same thing, ZNOH whole twice with KOH giving you K2ZNO2 plus water. And exact same things are happening, only your reactants are changed. That means instead of oxide you have a hydroxide, but the entire reaction is exactly the same, but the balancing has changed. So make sure that you pay attention on balancing of the equations. Now another thing on this section that you have to remember is zinc oxide and lead. Zinc oxide and aluminum oxide are white in color, lead is yellow in color. Zinc oxide and lead oxide will become colorless and soluble after the reaction. Everything else is same, nothing has changed. If you think about the first section, this one, all of them are colorless. Okay, so all of them, all the salts that you get, all the salts are colorless. So if you have to memorize something in characteristic, all of them are colorless. And when I talk about salts, I am talking about the product section. Okay, all the products that you're getting, all the product salts you're getting are colorless. Now let's move on to the next part. I think we have questions now. So the first question is, yellow monoxide that dissolves in hot concentrated caustic alkali. So yellow monoxide is PbO. So make sure that you remember the colors. Okay, so the yellow one is PbO. Then in the next one you have a white insoluble oxide that dissolves when fused with caustic soda or caustic potash. So a white insoluble oxide would be ZNO that I told you. So ZNO is a white insoluble oxide that becomes soluble or that dissolves after the reaction. Okay, so your answer would be ZNO. Next question is, what is observed when hot concentrated caustic soda solution is added to zinc and aluminium? Write balanced chemical equation. So in this question, I have seen majority of mistakes happening, that the students have written the equation but did not mention the observation. So the question is clearly asking you what is observed. So first thing is, you have to write the observation. Second thing is, you have to mention a balanced chemical equation. So let's look at both of them. So when we talk about the first, that is so let's come on the first section. We are on here. When we talk about observation, so in observation you will be giving the compound, but along with that, in observation you can mention that you get a colorless salt, that is sodium zincate, and you get a colorless odorless gas which burns with a pop sound. So in this case you are giving them an observation that a colorless odorless gas is coming out and it is burning with a pop sound, and a colorless solution is obtained. What is the colorless solution? That is sodium zincate. What is the gas coming out which is burning with the pop sound? That is hydrogen gas. Okay, so I hope that makes sense. And the next one they have asked is for aluminium, and aluminium also you can say the same thing. You get a colorless solution, but you get a colorless odorless gas which is burning with the pop sound, that is hydrogen. And you can also mention any of these equations. So one for zinc, one for aluminium, directly from this. Now let's move on to the next part of the question. We are on question 3. What do you understand by amphoteric oxides? So we just did the definition of amphoteric oxides. Give the balanced equations for the reaction with two different amphoteric oxides with a caustic alkali. Name the products formed. So this is the question that I was talking about. Name the products formed. Okay. So let's come on your amphoteric oxides. So this is the section of amphoteric oxides. You can pick up any two that you're comfortable with. Majority of students pick zinc oxide and lead oxide. So you can pick up that. ZNO plus NaOH gives Na2ZNO2 plus water. Same thing for PbO plus NaOH gives Na2PbO2 plus water. Now, what else they have asked? What is the name of the products? So for the first one, you can mention sodium zincate, and for the second one, if you are picking up lead, you can mention sodium plumbide. If you are picking up aluminium, you can mention sodium aluminate, sodium meta aluminate. Okay, so these will be the names of the compounds. If you would like, I can write them right here so that you don't make any mistakes. So you'll say sodium zincate, or you can take lead sodium plumbide, and if you're taking aluminium, you'll take aluminium. So sodium meta aluminate, sodium meta aluminate. Now these are the answers. If you're taking up so these answers will be directly based upon what equation you're taking up. If you're taking NaOH, then you take sodium sodium. If you're taking KOH, then take potassium potassium potassium. So these answers are directly related to what equations you're using. Okay, so I hope that makes sense. All right, my dear students, so this is where we end up today's session. Now, one important thing for you is that we have covered everything in analytical chemistry. We have done anion detection, cation detection, and the last portion, that is action of alkali on metals, metal oxides, and metal hydroxides. Along with this, I have also solved a test paper on analytical chemistry, which contains mixed questions from the entire chapter. So all of this section is important. With every part of analytical chemistry, I have done important questions at the end of the video, and then there is an test paper also. So you have a lot of practice questions available, and you also have a lot of notes available. So make sure that you download all the notes from the description box, or you can join the Telegram channel because I keep posting the notes there, so you can directly get them in your chat. So whatever works for you, you can do that. So thank you so much for everything, and I hope you have a beautiful day. Make sure that you like, subscribe, and share this channel and help us move forward. Thank you.